understand about waves, the basic of the waves. So, what do you think about what is waves? Waves transfer energy and information. Waves are described as oscillations or vibration about a fixed point. For example, ripples causes particles of water to oscillate up and down. Sound waves causes particles of air to vibrate back and forth. Or in other words, a wave is a disturbance that travels through matter or space as a series of oscillation carrying energy. This is important to write carrying energy because in the definition if you'll miss to write carrying energy that the wave carry energy without the movement of any matter, so the mass can be reduces. In all cases wave transfer energy without transferring matter. For water waves this means it is the wave and not the water, the matter itself that travels. For sound waves, this means it is the wave and not the air molecules, the matter itself that travels. Alright, objects floating on water provide evidence that waves only transfer energy and not matter. So here's the step 1 to identify the type of wave. So basically there are two types of wave. First of all, the type of wave on the surface of a body of water is a transverse wave. This is because the duck is moving perpendicular to the direction of the wave. And there is another type of wave called longitudinal wave. The longitudinal wave is called the parallel. It means that the transverse wave is perpendicular and the longitudinal wave is parallel. Step 2. Describe the motion of the toy duck. The plastic duck moves up and down but does not travel with the wave. Alright, step 3. Explain how this motion demonstrates that waves do not transfer matter. Both transverse and longitudinal waves transfer energy, but not the particles of the medium. What does a medium means? Is it means simply any particular particle or what we can say as a matter. This means when a wave travels between 2 points, no matter actually travel with it. The points on the wave just vibrate back and forth about fixed positions. Objects floating on the water simply bob up and down when waves pass under the pass under them, demonstrating that there is no movement of matter in the direction of the wave, only energy has the direction of the movement. Okay, so there are the wave motion. As I talk about the transverse wave, wave vibrations can be shown on ropes, transfer, and springs as longitudinal wave. First of all, talking about the ropes in the vibration in the ropes. Wave travels perpendicular to the vibration of the rope. In the green arrow, you can see the movement of the energy from A to B, and the vibration of rope is you can see from the red arrow. Vibration in springs. Wave travel parallel to the vibration of coils, and here again the movement of energy is from A to B, while the vibration of coils is also from A to B. Demonstrating wave motion. Properties of waves such as frequency, wavelength, and wave speed can be observed using water waves in a ripple tank. So here is given a light source support, wooden bar supported by elastic band, water, and a screen including the wavefronts. Alright, wave motion of water waves may be demonstrated using a ripple tank. What is a wavelength? The wavelength of the waves can be determined by using a ruler to measure the length of the screen, dividing this distance by the number of wavefronts. The frequency can be determined by timing how long it takes for a given number of waves to pass a particular point, dividing the number of wavefronts by the time taken. The wave speed can be determined by using the equation wave speed is equals to frequency multiplied by wavelength. This is the formula in the entire chapter which you are required to memorize. Wave speed is equals to frequency multiplied by wavelength. If they'll be for suppose that in the question they'll be giving you the value of wave speed and the frequency, and they'll be asking from you the wavelength. So you must understand how to just convert the mathematical formula. Features of a wave. This is very essential for you to understand. If you does not understand, you'll be unable to solve the questions from P2. When describing wave motion, there are several terms which are important to know, including crest or peak, trough, amplitude, wavelength, frequency, wave speed, and wavefront. First of all, crest and trough. I'll also showing you the diagram so that you will be understanding what is the meaning of crest and trough, including the other terminologies. A crest or a peak is defined as the highest point on a wave above the equilibrium or rest position. It means highest point on a wave above the equilibrium. A trough is defined as the lowest point on a wave below the equilibrium or rest position. It is on the lowest point on a wave below the equilibrium. Can you just see this diagram where the blue arrow shows the direction of energy transfer and the direction of vibration is showing by the red arrow. Crest is the highest point above the equilibrium and trough is the lowest point below the equilibrium. So these are the highest and the lowest point you're required to just remember, and that's very simple terminology. Again now, amplitude is defined as the distance from the undisturbed position to the peak or trough of a wave. Alright, it means that this is the undisturbed position to the crest or trough of a wave. It is given the symbol of A and is measured in meters. Amplitude is the maximum or minimum displacement from the undisturbed position. Now just see what is the amplitude here. From the equilibrium to the crest or from the equilibrium to the trough is called the distance is called amplitude, and because it is distance it is measured in meters. Wavelength. Wavelength is defined as the distance from one point on the wave to the same point on the next wave. In a transverse wave, the wavelength can be measured from one peak to the next peak. In a longitudinal wave, the wavelength can be measured from the center of one compression to the center of the next. Or what is the compression and what is the rarefaction? In the longitudinal, basically in the longitudinal wave, there are two terminologies and no amplitude is required. There is no trough or sorry, it's not there is no trough or crest, no amplitude, but what you're required to just memorize is the two terminologies used as compression and rarefaction. Some in case why many people complicate themselves in the word rarefaction, it means extension. But the examiner in the paper used the word rarefaction, so you must be aware of this word. The wavelength is given the symbol lambda and is measured in meters. Alright. The distance along The distance along a wave is typically put on the x-axis of a diagram. Alright, so the distance of wave travel, here's the wavelength. From the one crest to the next crest is called the wavelength, and similarly from one trough to the next trough is called the wavelength. The displacement is also having the symbol of x or s, whatever. So here's the frequency. Frequency is defined as the number of waves passing a point in 1 second. In 1 second, the number of how much waves have been passing in only 1 second is called the frequency. Frequency is given the symbol of f and is measured in hertz. Wave speed. Wave speed is the speed at which energy is transferred through a medium or a matter. Wave speed is defined as the distance traveled by a wave each second. Wave speed is given the symbol v and is measured in meter per second. It can be calculated using wave speed is equals to frequency multiplied by wavelength. What is the formula which I taught you. Wavefront. Wavefronts are an useful way of picturing waves from above. Each wavefront is used to represent a single wave. The image below illustrates how wavefronts are visualized. The arrow shows the direction the wave is moving and is sometimes called a ray. The space between each wavefront represents the wavelength. When the wavelengths are close together, this represents a wave with a short wavelength. When the wave when the wavefronts are far apart, this represents a wave with a long wavelength. Now you can see this diagram viewing waves from above, and these are the wavelengths. Sorry, they are the wave fronts. So if there is any question for you, you are required to just comment me below and just wait for the answer. And if you are new to our channel, also do not forget to subscribe, clicking the bell icon so that every live session and the videos must be on the time, and you'll be there for just watching the video. If you're having any confusion, you'll be required to just comment me and just wait for your answer till that it's here. It was the chapter number 12 of your physics, IGCSE and GCE O levels. And uh, take care.